All right, hello, my name is Brandon Clayton, the Algebra Guy, and today we'll be talking about, as you see on your screen, modeling and solving using the division property of equality. So at this point, we've talked about adding the addition property of equality, subtraction property, and now we're talking about division property of equality. So let's look at what that looks like, and I'm going to start out with some models, but first, let's talk about, as usual, the questions we want to answer. So the questions are, what is the division property of equality? How to use this property to solve an equation, and how to translate from a phrase to an equation and solve. So we're going to look at all those pieces now. Let me get my pens ready. There we go. All right, so let's get to our problems. So let's take this for instance. Now I don't have a manipulative that you can necessarily hold and kind of mess with. So I'm going to use this envelope. So imagine we have this envelope, and these two envelopes represent 2 times some number of coins or counters, as we're looking at here. And on the other side, we have our 6 positive counters. We want to know how much each envelope is. We want to solve for x in the sense and say x equals what? What is 1x equals, or in this case, 1 envelope equals? In order to solve that, using the division property of equality, basically we want to divide this left side into 2 so we can separate it into individual envelopes, because I want to know the cost or the value of 1 envelope. And I divide the right side into 2 as well. So when I divide the right side into 2, I'll do it this way. So there's one way I can divide it into these 2 groups. Now I know that in 2 groups, each group can hold 3 positive counters. So that means each envelope on this left side must hold 3 positive counters. So I divided this left side by 2, and I divide this right side by 2. So now I know I have, for every envelope, there's 3 counters. So that's the idea behind the division property of equality. The same thing will hold true for this problem, and I know you probably know how to solve this pretty quickly looking at it, but I want to model it for you, because as we get to the actual problems without this, it'll make more sense. So we got 3, but we don't know how much is in each. We have 6 counters over here. If we're going to divide these into 3s so that I can have 1 envelope each that I'm looking at, I'm going to divide this right side into 3s. And dividing this right side into 3s will look like this. Here's one way I can divide it. But either way you divide it, if you divide them in 3 equal parts, you're going to get 4 in each part. So that tells me in each envelope I can put 4 of these counters, which is a value of 4. This is not the right number. This should be 12. I just realized that. So this should be, this is if I had 3x equals 12, not 6. So if I divide that 12 into 3 parts, it can give me 4 each. Sorry about that. All right, so what is the division property? So in essence, here's what it's saying. If for any numbers a, b, and c, so just say some numbers are a, b, and c can't be 0, and I'm going to show you why here in a second. If a equals b, then a divided by c equals b divided by c. So let me write that, because sometimes you'll see the division sign written like this slash, or you'll see it written right on top of each other like this. So a divided by c is equal to b divided by c. So they're saying, well, if you have a equal to b, if you divide both sides by c, you have changed nothing in the value of that equation, because you did the exact same thing, in this case dividing by c, on the left side as you did on the right side. So if you do the same thing on the left side as you do the right, then you can still claim that this equation is true, that both sides are still equal. And we could plug in a number here, because sometimes it helps to actually put in a real number. So I don't want to use y. Let's use a different, let's just come up with a number. So 4 equals 4. That looks too much like a y. Let's use a different number. Let's use 5. So if 5 equals 5, well, I know that I can divide it by some number, and it's got to be the same number, as you see c and c. So the same number, it still should be equal. So let's divide it by this side by 2, and this side by 2. Well, when I do that, these both sides are still the same, 5 over 2 and 5 over 2. As a decimal is 2.5 and 2.5. So nothing changed. I just did the exact same thing on both sides. That's the division property of equality. It just says whatever you do on the left side, you need to do on the right side, and it keeps the value true. All right, let's practice some to see if you got it. Let's solve this problem. 7x equals negative 49. Well, I want to divide this 7 over here. Why? Because 7 divided by 7 gives me a 1x. And my whole goal is to solve. And when they say solve, I'm solving for a variable. X is our only variable here, so I'm going to solve for x. So 7 divided by 7 is 1x. I don't need to draw the 1 there. But I need to do the same thing over here. Divided by 7. So I had to do that because it says equals. In order to keep it equal, I need to do the same thing on the left side as I did the right side. 49 divided by 7 is 7. But a negative 49 divided by a positive, if you remember, different sign is going to give me a negative value. So this is going to be negative 7 in this case. All right, let's go to another problem. And I would encourage you as I'm going through these, keep in mind to try to work them yourself by pausing it and attempting to work it before I do. Maybe in your head or on a piece of paper. That's the fastest way to learn it. All right, so let's try this one. I want to divide by negative 3. Notice I didn't say 3, because if I just divided by 3, it'll give me a negative y. But I want to get rid of this negative. So negative 3 divided by negative 3 gives me a y. A negative divided by negative, if you remember, gives me a positive value, which is a positive 1. And that's what I'm looking for. So now I'm going to do the same thing on this side, which is divided by negative 3. 63 divided by negative 3. Well, positive divided by negative, first of all, is negative because they're two different signs. And dealing with multiplication and division, you're going to remember that rule. Different signs, when they're multiplied and divided, are going to give you a negative. So this is going to end up being 21. You know, if I were to work it out, 63 divided by 3. 3 goes to 6 twice, and 3 goes into 3 once. So we can see that's going to be 21, and it's going to be a negative 21. Pretty simple enough. Not too many steps involved. This is actually called a one-step equation, so just getting the foundation for us correct. So let's move on to something a little bit, I don't want to say complicated, but has an additional step to it. Solve this one. Well, what's different about this problem? Well, the thing that's different is we notice that everything's not written out for us in an equation in numbers. So we're going to have to first translate this, then solve it. So let's use our translation skills. 5 more than x. So we have an x already, and we have 5 more than that. Is the same thing as equal, if you remember in previous lessons. Is the same thing as equal to negative 3. So it pretty much wrote it out for us. If you know how to think through, this more than would be a plus, and obviously 5 is 5 and x is x. So you can kind of see the equation coming together. And yes, you could have written 5 plus x equals negative 3. You could have written it this way, because when you're adding two things, it doesn't matter the order, if there's going to be 5 plus 1 or 1 plus 5. So it didn't really matter the order because we're just adding them. Now subtraction is different, division is definitely different. These are commutative is what the name is. We're going to call that. But since it says 5 more than some number x, I started with that number first. Now let's solve it. In order to solve this, I need to get my x by itself. To get rid of this 5 over here, I only want x over here. I just wanted to say x equals something. Well, this 5 is in the way, so I got to subtract 5. I'm going to do the inverse operation. Instead of plus, I'm going to do minus. Why? Because plus 5 minus 5 gives me a 0 here. Well, I can't just do it on the left side. I need to do it on the right as well. So that leaves me negative 3 minus 5. Now, if I took away 3, if I had a number line, this is 0, and I took away 5 more, it's going to go back 5 more, and that's going to end up being a negative 8. So x equals negative 8. And remember, if you need help on those rules, go back to the previous lessons. It'll help and do some more practice problems to make sure you get that. Because those integers sometimes can trip us up when we're adding negative numbers or multiplying negative numbers or dividing negative numbers. All right, let's translate this one. The difference, what operation is that? Subtraction. The difference of n and 6. So the difference between n and 6. So those are the two things we're talking about, n and 6. The difference of these two, n minus 6, is, that's my equal sign, negative 10. So that's probably the hardest part, maybe, is translation for some of us, is trying to get into look like this. Now I know what I need to do to solve it. I want to get n by itself. So I want to get rid of this negative 6 over here. So I'm going to add 6, because that's the inverse operation of a negative 6, or subtract 6. And I'm going to add 6 here. This leaves it with n, and if I add this up, this gives me a 0, so I can leave nothing there. If I add this up, I know that I'm going to take the sign of my bigger value because I'm adding, and I notice that the 10 is my bigger value, so it's going to be negative. I'm going to add 6 more to that, so that's like 10 minus 6, which is 4. Now, I do want to say one quick thing that comes up in discussions with some of my students, and that's something I said right here when I said n minus 6 and you add 6. So the question I get a lot is this a subtraction sign or a minus sign? I'm sorry, a negative sign or a subtraction sign. Now, I want you to remember that n minus 6 is equal to n plus negative 6. So this is a subtraction sign. I'm just going to subtract. And this is a what? Negative sign. All right? So what's the difference between subtraction and negatives here? So hopefully you can answer that question, because that's the question I get a lot. Is this a subtraction sign or a negative sign? And really, this sign is telling me that it doesn't matter, because subtracting a value is the same thing as adding the negative of that value. So you can look at it either way you want to. So I say yes, it's subtraction and it's a negative. No matter how you use it, you're still going to come up with the same value. So keep that in mind so you're not confused that they're the same thing. Let's try another one. The number 108 is the product. Okay, the product of something. What operation is that? Adding, subtracting, multiplying, or dividing? Well, product is telling us that we're multiplying something. It's the answer of something that we're multiplying. So the number 108 is the product. So 108 that's the product. That's the answer for some numbers. That's the product of what? Oh, it's a product of negative 9 and, because I know I'm multiplying, y. All right, so I kind of heard somebody say, just while I just did that problem, is could I have switched those? Could I have said 108 equals y times negative 9? Absolutely. Because, and we may get into this later, but that's a commutative law that says 3 times 2 is the same thing as 2 times 3. You can switch places with multiplication and addition, but you can't do that with division and subtraction. So you'll see that in some of our examples. So yes, you could have written it that way. So I just kept it the same. Most of the time, you're going to keep it in the same order when they give you these phrases. So I would do that to be on the safe side. All right, did we accomplish our goal? Let's look at our goal and not the white screen. What is division property of equality? How do we use this property to solve an equation? What is the division property of equality? The division property of equality we just talked about was that you could take any numbers that are equal to each other, any two sides that are equal. Let's say 3 equals 3. And if you divide those two sides by any number, any of the same value, c is going to be they're still going to be equal. So if I divide this by 4 and this by 4, it's still going to be equal. Now, just to push that point a little bit further, you can still have 3 and 3. What if I divided this by x plus 1 and this by x plus 1? Would those still be equal? Absolutely. Why? Because this whole thing can represent C and this whole thing can represent C. That's some number. We don't know what X is, but it's going to be some number if we plug in a value for it. So it can look pretty complicated, but it's still going to be the same idea. Divide both sides by the exact same thing. They're still going to be equal. How to use this property to solve an equation? We just showed it by dividing that same value. On both sides. So if we have 15, we're going to divide both sides by 3, and that'll leave us with our x value to finish. How do you translate from a phrase to an equation? Again, we've shown that in a couple of videos, and now with the division video, that the word is equals our equal sign, and that the sum equals plus, and product is talking about the multiplication. So we discussed that in those examples. So yes, we've covered everything. Guys, thank you for tuning in. Again, my name is Brandon Clayton. I'm the Algebra Guy, and I will see you next lesson.